we want to calculate this integral. You have 1 plus sine x divided by 1 minus sine x, and you want to know what is the integral with respect to x. So u sub doesn't work here. Partial fractions doesn't work here. Let us try to get rid of denominator. Now let us use the conjugate of the denominator and try to simplify. So from algebra, remember that if you have a quantity, if you have an expression or a term like a minus b, its conjugate is a plus b. So you only change the sign in between. If the term was a plus b, the conjugate is a minus b. So you're basically switching the signs. So on the denominator, you have 1 minus sine x. The conjugate of 1 minus sine x is 1 plus sine x. Now multiply both the numerator and the denominator by the conjugate, which is 1 plus sine of x. Very good. So the integral of, let's see, 1 plus sine x divided by 1 minus sine x multiplied by the conjugate. Remember that you have to have the conjugate both on the numerator and on the denominator. Otherwise, it's going to change your integral. It means that you're creating something out of nowhere, which is wrong. So let's see what's happening here. Let us simplify as much as we can. Here we go. Your integral becomes, well, on the numerator, I'm going to have 1 plus sine x raised to power 2. On the denominator, what I see here, on the denominator, I have a minus b. Let me write this guy from algebra. If you have a minus b times a plus b, this is a squared minus b squared. So if I multiply 1 minus sine x by 1 plus sine x, this is 1 squared minus sine squared of x. Or this is 1 minus sine squared of x, right? Okay, perfect. Let's see. So on the denominator, I have 1 minus sine squared. Let us for now copy this guy down here. Then we are going back to pre-calculus and simplify this further. You get the integral of 1 plus sine x to the second power divided by, remember that from pre-calculus, sine squared plus cosine squared is 1. Cosine squared of alpha is 1. So 1 minus sine squared is cosine squared. Wherever we see 1 minus sine squared, we can use cosine squared. So on the denominator, you're left with cosine squared of x. Okay, how do I take this integral? My numerator is sine squared of x plus 2 times sine x plus 1. My denominator is cosine squared of x dx. So again, from algebra, remember that if you have a plus b to the second, it is a squared plus, I'm writing fast, my handwriting is just a little bit messy. So if you have a plus b to the second, this is a squared plus 2ab plus b squared. So when you have 1 plus sine x to the second power, you get 1 plus 2 times sine x plus sine squared of x, but the order is not important. You get sine squared plus 2 sine plus 1. Now separate this integral into 3 integrals. Into 3 integrals. The very first integral is the integral of sine squared of x divided by cosine squared of x dx plus 2 times the integral of sine x divided by cosine squared of x dx plus the integral of dx over cosine squared of x. So now just take the integral as easy as that. The very first integral is the integral of tangent squared of x dx. The second integral is basically using u sub. You get 2, you have a negative sign as well, integral of negative sine x dx, and we have to have a negative sign in front. So let me just write down this guy in front of it, minus 2 divided by cosine squared of x. And then here you have the integral of 1 divided by cosine squared. Remember that secant is 1 over cosine. So you get secant squared of x dx. Could we combine these together and write this in a nicer format? For example, tangent to the second power can be combined with the secant squared, make it a little bit easier to do the computation? Yes, of course, we can do that as well. So this integral can be written as the integral of, so for our tangent squared, we're going to write it as secant squared minus 1, and we end up with 2 secant squared. So let's see, 2 secant squared minus 1 dx, and then here you have minus 2, the integral of du divided by u squared. And then for the integral of secant squared, you're going to have just tangent. Let me see. Here we go. I didn't want to write this in this form, but that's fine. So here you have two tangent of x minus x plus 2 divided by u. My u is cosine of x plus constant of integration. So I get 2 times tangent of x minus x plus 2 secant of x plus constant of integration. So this is another method applying the conjugate and seeing that the conjugate of the denominator, even though it's not in radical form, help us to simplify this integral and calculate the integral a little bit easier.